Why can plastic fibers worth only a few dollars become a wig worth hundreds of times more when it leaves the factory? That value does not come from the material itself, but from the way the factory transforms it into hair-like fibers. With fineness, shine, color, and movement that closely resemble real hair. From raw plastic being drawn into fibers, heat-treated, color-adjusted, styled, and assembled layer by layer, every stage contributes to turning a low-cost material into a product with an appearance so natural it is almost unbelievable. We'll take you through the entire journey of creating a wig to see how a seemingly ordinary material
can become a product that changes a person's appearance, style, and confidence.
A wig is not simply an accessory. It is a technical legacy with a history of more than 3,000 years.
From wigs made of beeswax and plant fibers worn by Egyptian pharaohs, to the fashion icons of 1970s movie stars, this item has evolved into an industrial empire.
Worth more than $13 billion by 2026.
What truly defines the class of this industry is not only the output of hundreds of millions of products each year, but the intersection between medicine and precision engineering. For millions of patients fighting cancer or other serious illnesses, a properly made wig is the most valuable recovery tool for confidence. This is one of the rare manufacturing processes in the world that requires a strict combination of heavy industrial machinery and manual operations refined down to every millimeter.
To understand why an item that seems so simple carries such complexity, we will move to the first stage of the process.
Pundi, material preparation.
Everything begins with large containers of synthetic hair fibers,
often weighing around 25 kilograms each. Inside are long, continuous polypropylene fibers, wound like thread in the textile industry. This is the raw material form, with no shape or hair-like properties yet, but it serves as the foundation for the entire process that follows. At the feeding area, the fiber rolls are placed onto racks and pulled out through a guide system. Rollers and guide bars keep the fibers straight, preventing them from twisting or tangling as they move. Once they are pulled out steadily, the fibers are fed into a cutting machine to divide them into sections of precise length, usually around 16 inches, depending on the product design. The cutting system operates continuously, ensuring that every bundle of fibers has a uniform size. Finally, the cut fibers are gathered into small bundles with standard weight and length. This is the material form ready to move into the next treatment stages, where the plastic fibers begin to be transformed, so they can look and behave more like real hair. After being cut into bundles of uniform length, the fibers enter one of the most important stages, combing and alignment. Here the hair is pulled across a metal board
with hundreds of sharp pins, commonly called a hackle. As the fibers pass over this surface,
strands that stick together are separated, while the entire hair bundle is pulled straight in the same direction. Weak, overly short, or defective fibers are also caught and removed during this process, helping ensure consistent quality in the material.
This combing step is not simply about detangling, it also helps reorganize the structure of the hair.
The fibers are redistributed in a more natural way, no longer lying in perfectly straight lines as they did when first cut. This slight irregularity is what creates a softer and more realistic feel when seen by the eye. In some production lines, hair may also be lightly blended between different color shades to increase color depth, but the main goal remains making each strand behave like real hair.
just imagine if every hair fiber were perfectly straight and identical. Would it still look natural?
After the hair has been straightened and rearranged, the bundles no longer remain as loose fibers. At this stage they are fed
into a specialized sewing machine to create a completely new structure. Hair strips, also called wefts. The machine system holds the root section of the hair fibers firmly, then uses industrial needles to stitch them into a continuous line.
As the machine operates, the fibers are fed in evenly, creating long strips that can be rolled up or pulled out according to production needs.
The important point here is not simply sewing them together, but controlling the thickness and coverage of each strip. If it is too thin, the hair will not have enough volume when mounted onto the cap. If it is too thick, the product will become heavy and unnatural. For that reason, workers continuously adjust the amount of hair being fed into the machine, while also checking the width of the strip to ensure uniformity. Once completed, the hair strips are stacked into multiple layers, forming ready-made modules for the next assembly stage. This is the moment when loose hair fibers become part of a complete structure for the first time.
Part of a complete structure for the first time.
After being sewn into strips, the hair cannot be styled immediately. It first needs surface treatment to stabilize its structure.
The hair strips are dipped into a conditioning solution to reduce static electricity and soften the fibers.
When the solution coats the fibers evenly, the hair becomes easier to control, limiting frizz or sticking during the next treatment stages.
The excess solution is then removed, bringing the hair to a slightly damp state. In this condition, the hair is soft enough for styling, but still stable enough for the processes that follow.
Here, the raw fibers are treated in a precise boiling process. Once conditioned, we determine the final style: curly, wavy, or perfectly straight.
Once stabilized, the hair strips are brought into the styling stage, where the final shape of the product begins to be established.
First, the hair is combed straight again to ensure the fibers are not misaligned. Then, depending on the design,
the hair is either wrapped around metal rods or braided to create waves. The size of the rod determines the curl pattern. Larger rods create gentle waves, while smaller rods create tighter curls. The hair rods are then placed on racks and moved into an industrial drying oven. Temperature and time are tightly controlled, usually lasting from 30 to 60 minutes, so the hair fibers can memorize the new shape. At the end of the heat cycle, the hair is not handled immediately, but must go through a cooling stage with fans, helping lock in the newly formed structure. Finally, the hair is removed from the rods, keeping the style that has just been shaped, ready to be assembled onto the cap. Before any hair fibers attach, the entire structure must begin with a foundation layer capable of imitating a real scalp. This layer is made from ultrafine nylon or polyester fibers, nearly transparent, which are fed into an industrial weaving system to create a mesh or lace form. These fibers are stretched and continuously supplied into the system, where weaving needles move rhythmically to interlace each fiber according to a fixed pattern. As the machine runs, each row of mesh is continuously formed, creating a long sheet of material with a uniform structure.
Throughout this process, the weaving speed and the spacing between fibers are directly adjusted on the machine to ensure the mesh openings are not misaligned or too dense.
Once the mesh sheet is completed, it is pulled out of the machine, rolled up, and transferred to inspection. The sheets that meet requirements are kept, ready to enter the next stage of cutting and forming the cap structure. When the hair strips have been fully processed and shaped, they still cannot become a wig without the base structure
that holds everything together. Here, the process moves into building the cap frame.
The part that determines the final shape of the product. The worker begins by wrapping the thin mesh layer
around the entire mannequin head mold, stretching it so the mesh closely follows every curve of the surface. Right after that, a layer of glue is applied evenly across the entire mold, helping secure the mesh and create adhesion. While the glue is still wet, the mold is placed into a heated oven to dry and stabilize the material.
allowing the mesh layer to hold firmly to the intended form. Once the mesh layer has stabilized after heating,
another thin mesh layer is placed over the mold to increase the strength of the entire structure.
This layer is stretched and temporarily fixed with pins, keeping the surface closely attached to the head form.
Immediately after that, specialized adhesive tapes are applied along predetermined lines, creating a positioning system
for all the hair that will be added later. These tape lines are not simply used to hold the form.
They also act as a map, clearly defining the position of the hairline, crown area, and the sides of the head.
The factory worker aligns each section of tape along the natural curves of the mold to ensure accuracy. Once the areas have been shaped, the excess mesh is cut away. Then the mesh layer is removed and sewn permanently along the tape lines. The result is a complete, sturdy base structure, ready for the next stage of attaching the hair. Once the frame is completed, the hair strips, or wefts, begin to be attached to create the full structure. The worker places each hair strip onto the cap and sews it in place, starting from the lower section and gradually moving upward. Each stitched line is aligned so the hair spreads evenly across the entire surface,
avoiding areas that are too thick or too thin.
During this process, hair density is continuously controlled by adjusting the amount of hair on each strip.
At the same time, the falling direction of the hair is arranged from the moment it is sewn,
helping the finished fibers fall more naturally. If the hair strips form most of the structure.
the hand tying stage is the factor that determines how realistic the product looks. At the crown area, the part most easily exposed when viewed from the front.
each hair fiber is hooked into the mesh using a small specialized needle.
The worker inserts the needle through the mesh, pulls a few strands of hair through, and ties a knot to secure them. This process is repeated thousands of times, strand by strand, with intense concentration. The difficulty lies in controlling the growth direction of each hair fiber.
It is not simply attached. Each strand must be placed at a certain angle to imitate the way real hair grows and parts.
Thanks to this stage, the crown no longer feels artificial, and the parting line can be seen clearly like real hair. This is also why a high-quality wig can take hours, even dozens of hours, just to complete this area alone. Once all the hair has been attached and hand-tied, the product enters the final finishing stage.
First, clips or fastening accessories are sewn inside the cap, helping the wig stay secure during use.
Then, the hair is washed clean to remove dust, glue, or remaining impurities from the manufacturing process. In its wet state, the hair fibers are combed and rearranged, then passed through a drying system to dry evenly. Once the hair is dry, the worker performs the final styling, adjusting volume, fall, and hair direction to achieve the desired shape. Any excess or uneven hair is lightly trimmed to complete the overall look. This is the step that turns a technical product into an aesthetic product, ready for real use. Before leaving the factory, every wig must go through a quality inspection process. Here, the wig is labeled with detailed information, such as color, size, or product code. Finally, the product is carefully packaged and prepared to enter the distribution system, ready to reach the user. From the initial raw plastic fibers, through a series of stages from treatment and shaping to assembly and finishing. A wig is not simply a product of machinery, but a combination of engineering and meticulous attention in every detail.
Each step in the process plays its own role, but it is the way they connect with one another that creates a product capable of recreating the natural appearance of real hair. Behind a finished wig are dozens of working hours, from industrial production systems to manual operations that require high precision. And when the product leaves the factory, it is not only a useful item, but also carries practical value,
helping users regain confidence in everyday life.
If you want to discover more fascinating manufacturing processes like this, so you won't miss the next videos,